All right, this is Notes T Part 3, and here we're going to start looking at solving rational inequalities. So now we're throwing in that less than, greater than, less than or equal to, greater than or equal to. Now, in the first thing I want to do is work through the steps with you, outline them so you've got something that you can refer back to, and then we'll go into some examples. So the very first thing we want to do is we want to make sure that the 0 is on the right side of the inequality. If it isn't, we're just going to do some work so that we get that inequality over on the right, or that 0 over on the right-hand side of the inequality. Okay. We also want to make sure that the left side is simplified into one fraction, and that we go ahead and factor the numerator and denominator as well. As a little side note, it is possible to have zeros or undefined values even when your numerator or denominator doesn't factor. So just kind of keep that in mind. Okay. So once we've got that 0 on the right-hand side of the inequality and we have that left-hand side as a single fraction and factored, step 2 is to find the values of x that are zeros of the function and values of x where the function is undefined. So remember, I mentioned before that these are called the critical values. Okay. Remember that zeros come from the x values that make the numerator equal to 0. So to find our zeros, we set the numerator equal to 0. And the undefined values come from the values that make the denominator equal 0. And we need to make sure that we find both the zeros and the undefined values as well, both of them. Now, once we've done that, step 3 is going to be to plot these critical values on a number line. Okay, so we're going to simply draw a horizontal number line, and we'll put whatever our critical values are on it in order from left to right, least to greatest. The fourth step is to use the graph or a sign chart. So we'll talk about sign charts in our examples to determine the sign of the function in each interval along the number line. So remember, we saw that in the previous part for this set of notes where we talked about positive is above the x-axis, negative is below the x-axis. That's where we're determining the sign. Okay, and we want to determine this for each interval on our number line. And then step 5 is going to be to give the solution. When we give the solution, if my rational function is less than or equal to 0, our solutions intervals will be where the function is negative. So remember, less than or equal to 0, we're looking negative, we're looking below that x-axis. If my rational function is greater than or equal to 0, the solution intervals will be where the function is positive. So from a visual standpoint, we're talking where it's above the x-axis. And we never include in the solution values of x for which the function is undefined. So that's going to be important when we talk about parentheses versus brackets. If it is undefined or DNE, where we've got that vertical asymptote, we're always going to make sure that we use parentheses on those numbers. All right, so here's our first example. We have x minus 2 over x squared minus 9 is greater than 0. Okay? Just as a heads up, if you decide to use your calculator in assisting you on this, be very aware that you want to make sure you use parentheses around the numerator and parentheses around the denominator. Now, step 1 was to make sure that we have our 0 on the right-hand side of our inequality, that our left-hand side was a single fraction, but we also want to make sure that we factor the left-hand side if possible. So, we're already got that 0 on the right. Cha-ching, we're good with that. X minus 2 can't be factored, but we can factor that denominator into x plus 3 times x minus 3. That's that difference of squares, and it is greater than 0. Now, in step 2, I need to find my zeros, and I need to find where my function is undefined, where it's DNE, where I have those vertical asymptotes. So, if I want to find my zeros, I set my numerator equal to 0. So I'm going to have x minus 2 equals 0. And I'm going to find out that my 0 happens when x equals 2. Okay. If I want to find out where my function does not exist, where it's undefined, I am setting x plus 3 times x minus 3 equal to 0. That denominator equal to 0. Each factor is going to get set equal to 0, and I'm going to get two solutions here. I'm going to get x equals negative 3, and I'm going to get x equals positive 3. Now, step 3 and 4 kind of happen visually in the same place. But step 3 is to draw our number line, and on it we're going to put our zeros and our x values where my function's undefined. So I'm putting negative 3, 2, and 3 on my number line. Make sure you put them in order from least to greatest, left to right. And I'm actually going to go ahead and do something on this number line that I didn't mention before, but I find that it can be helpful in later steps. Underneath negative 3, I'm going to write DNE. Underneath the 2, I'm going to write a Z for 0. And under the 3, I'm going to write a DNE. Just reminds me why those numbers made that number line. It's going to help me in determining my parentheses or brackets later on. All right, step 4 now is to determine my signs in each of these intervals, whether my graph is positive or negative. So when we talk about in each interval, the first interval we're looking at is in negative infinity to negative 3. Now, from negative infinity to negative 3, you can do two things. You can either A, use your graphing calculator and enter in your graphing calculator y equals x minus 2 divided by x squared minus 9, using those parentheses, and get a picture. You're then going to look on your graph to the left of negative 3 to determine if it's positive or negative. The other thing that you can do is you can say, okay, I'm going to find some value in this interval, let's say maybe negative 4, and I'm going to plug negative 4 into my function. If I plug negative 4 into my function, I would get negative 4 minus 2 over negative 4 squared minus 9. And I need to determine if that gives me a positive or negative output. -4 minus 2 is going to give me a -6. -4 squared is going to give me a 16 minus 9. So overall, I'm going to get that this is -6 over 7. Therefore, in this interval, my sign chart is negative. It's less than 0. Okay. I need to do the same thing for each interval here. Okay. If I'm going to plug in values, I might want to plug in 0 here. I might want to plug in 2.5. Maybe 4 in this interval. Okay. I personally tend to kind of bounce back and forth between the two methods of either plugging in values or looking at my graph. Either is acceptable. If you do choose to look at your graph here, you're going to find that it's negative in that first interval. It's positive in the second interval. Then it comes down to be negative. And then it's back to positive in that last interval. So my sign chart is going to be negative, positive, negative, positive. Okay. Now the very last step is to answer the question. You have to make sure when you're answering the question that you refer back to the original problem. This is greater than 0. So we want to know when it's positive. And because it's greater than 0, we're going to make sure that we use parentheses. There are not going to be any brackets in this one. So we are looking at the interval from -3 to 2. And again, the interval from 3 to infinity. That right there is my final solution. All right, let's try another one. This time we want to solve the inequality x squared minus 6x plus 8 over x squared plus 16x plus 64 is greater than or equal to 0. Okay. Now again, if you are choosing to put this into your calculator to get a visual idea of what this looks like, you've got to make sure that you're using your parentheses. Okay. Now, in step 1, I've already got my 0 on the right-hand side. Awesome, thumbs up. But I'm going to factor that left-hand side. So I'm going to get, let's see, x and x, 4 and 2, and both of these are going to be negative. And in my denominator, I'm going to have x and x, and I need something that's going to multiply to 64, 8 and 8 sounding good. And these both need to be positive in order to add up to a positive 16. All right, and this is greater than or equal to 0. Step 2, we're finding those zeros and those D&E values. My zeros come from when my numerator equals 0. So I'm setting x minus 4 and x minus 2 equal to 0. I'm going to get x equals 4 and x equals 2. My D&E is going to come from when my denominator equals 0. Now, I'm technically going to get the same solution here twice, but I'm only going to use it once, so I get x equals -8. All right, we're making a number line. On that number line, I'm going to have -8, 2, and 4. And I'm just going to remind myself -8's on that number line because it doesn't exist. 2 is on there because it's a 0, and 4 is on there because it's a 0. All right, now either using the image on your graphing calculator that you've come up with, or plugging values into each interval, we should be able to come up with a sign chart that is positive, positive, negative, positive. Now, notice that my signs just don't automatically alternate. This is an important thing to realize because sometimes students kind of get stuck in the habit of thinking that they're always, if the first one's negative, then it must be positive, negative, positive. That's not always true. So it's important to make sure that you're either referring back to the graph in your graphing calculator and looking at where it's above and below the x-axis, or that you're plugging in values in each interval. We find that when we do that, in this case, they don't always alternate. It goes positive, positive, negative, positive. Now, that was step 4. Now we got to do step 5, which is that final answer. We got to refer back to the original, greater than or equal to 0. So because it has that equal to, we've got to consider whether to use a parenthesis or a bracket. I'm also looking for where it's positive because it's greater than or equal to 0. So I am looking from negative infinity to negative 8. My negative 8 is DNE. Because it's DNE, it automatically gets a parenthesis. Union for that next piece. Negative 8 again is going to get a parenthesis because it's DNE, and I'm going up to 2 this time. Notice that 2 is a 0, and that I want to know when it's greater than or equal to 0. So that 2 is actually going to get a bracket. And then the last interval I'm looking at here is going to be from 4 to infinity. 4 is a 0. This is greater than or equal to 0, so it gets a bracket, and infinity always gets a parenthesis. So that right there is my final answer. Okay, now in this last example, something's not right. Right off the bat, when we're asked to solve the inequality, x plus 8 over x plus 7 is less than negative 3, we should notice that this is not 0. We've got to make it a 0. Here's how we're going to do that. We are going to add the 3 over to the left-hand side. So that very first step, we want to make sure that we have 0. Oops, I wrote a 3 instead of an 8. We want to make sure that we have 0 on the left side of that. Okay, I'm trying to erase and talk all at the same time. Rewind for me. We want to make sure that we have 0 on the right-hand side of the inequality. So we have to move the negative 3 over to the left. In order to do that, we are going to add the 3 to the left-hand side, and this is now going to be less than 0. Okay. Within that first step, we also need a single fraction on the left-hand side. Now that I've moved that 3 over there, I don't have that anymore. So in order for me to add these two things together, I need a common denominator. My common denominator is going to be x plus 7. X plus 8 over x plus 7 already has that common denominator, but I need to add a common denominator of x plus 7 to that 3, which means the numerator also needs an x plus 7, and this is going to be less than 0. We're going to clean this up a little bit. We can distribute that 3, and we're going to have x plus 8 plus 3x plus 21 all over x plus 7, that common denominator. We got a couple like terms we can combine. So x plus 3x is going to give me a 4x, And 8 plus 21 is going to give me a 29. So we get 4x plus 29 over x plus 7 is less than 0. Now, we also, if we can, want to factor that. 4x plus 29, there's no greatest common factor. It's not a difference of squares, so can't do anything with it. Same with x plus 7, so we're going to leave it like it is. Now, keep in mind, at this point, if you are putting 4x plus 29 over x plus 7 into your calculator, you have got to make sure that you are using parentheses. All right, step 2. We want to find our zeros and we want to find our D&E. Zeros come from when the numerator equals 0. So when does 4x plus 29 equal 0? That's going to happen when x equals negative 29/4. And now we get to find where our function doesn't exist. That's going to happen when the denominator equals 0. So we're going to get x equals negative 7. All right, these two numbers need to go on my number line. Think about this, negative 29/4. That's going to be further to the left on our number line than negative 7 is. If it helps you, you could convert that into a mixed number or a decimal just to kind of check that. But the importance is that it's to the left of negative 7. Negative 29/4 is on there because it's a 0, and negative 7 is on there because it's D&E. Now, at this point, we need to fill in our sign chart. You either can put that 4x plus 29 over x plus 7 into your graphing calculator to see what it looks like. If it's positive, it's above the x-axis. If it's negative, it's below the x-axis. Make sure you use those parentheses, though. Or we can plug in x values in each of those intervals and determine algebraically whether it comes out positive or negative. When you do that, you should find out that you get a positive, a negative, and then a positive. We got to answer our question now. The very last step. So filling in those signs was step 4. Step 5 is to answer that question. Got to refer back to the fact that it's less than 0. I am looking for where this is negative. So we're looking at negative 29/4 to negative 7. Notice that this is less than 0. Because it's less than 0, there's no equal to in it. These automatically both get parentheses. There you go.